This is my lab report for Lab 2, the line charge model by Magee. So the purpose of the experiment was to find the charge of a charged piece of tape using the gravitational force and the electric force and an understanding of the relationship between the two forces, as well as calculating the charge using a sophisticated model, which was the line charge model. In the experiment, Newton's second law of force is being used to state that the gravitational force is equal to the electric force. Since the piece of tape is motionless and they will equal each other. The interaction between the electric field and the electrical force is applied to find the charge of the piece of tape, and Coulomb's law is used to find the electric field. And a conclusion made was the piece of tape had a positive charge. So the data found was the length was 0.192 meters, and since the assumption was 1 gram was equal to 1 meter, the mass was found to have 0.192 grams, or 1.92 times 10 to the negative third kilograms. Separation distance was 0.045 meters. The gravitational force was equal to the mass times g, which was equal to 1.92 times 10 to the negative third times 9.81 meters per second squared, which was equal to 0.0188 newtons. As stated, since the piece of tape was motionless and the acceleration was equal to 0, the gravitational force and the electric force was equal, so the electric force was equal to 0.0188 newtons. The charge was found by taking the square root of the force of gravity times the distance squared times 4 pi epsilon naught, which is equal to the square root of 0.0188 newtons times 0.4045 meters squared divided by 9 times 10 to the negative 9 Newton meters squared per Coulomb squared, which gave a charge of 6.509 times 10 to the negative 8 coulombs. The setup was pretty basic, with a piece of tape being held suspended by 2 books, and then another piece of charged tape repelling it upwards. So in the code, there are 2 assumptions made: that there was no air resistance, and that the piece of charged both pieces of charged tape had the same charge. These assumptions were used to find the line charge model. Also, in the model, the charges it was assumed that the charges were distributed across the tape instead of at a center as one point charge, so as individual charges. And using the model, the charge was found to be 7.9164 times 10 to the negative 7th coulombs. And here's the, as can be seen, is the model. And also found was that the magnitude of the electric force was equal to 1.7625 times 10 to the negative third, and the magnitude of the gravitational force was just negative 1.7625 times 10 to the negative third. So it was the questions were, if in the model the charges were treated as a single point charge, then the charges would be 6.509 times 10 to the negative 8 coulombs, while which was different from the line chart, the charged line model, which was 7.9164 times 10 to the negative 7 coulombs. The answers differ because the line charge model, in the line charge model, because instead of there being one charge point, the charges are treated as having multiple individual charges which could differ, and then the line charge model is more accurate because it separates the top and bottom pieces of tape with individual charges instead of a singular charge, which would grant more accurate summation of the charges.